Okay, so let's do this. So when you pull your meter out of the box, you get the meter itself, the meter leads, and this little yellow bag, or this bag containing this yellow probe, is a thermocouple. You'll use it in your temperature classes. It's used to measure heat. So for right now, we're just going to push it aside. So in the notes, the first thing it says to do is connect the meter probes up to the correct points on the meter itself. So this is a meter, these are the meter probes. I want to show you something about the meter probes. So the meter probes themselves have two ends. The end kind of shaped like the angle, the straight angle, is the end that connects to the meter itself. Now it's pretty color coordinated, but these pieces have these little keepers on the end of them that need to be removed before you plug them into the meter. So first of all, the black hole is where the black lead goes. Now it's labeled COM. COM is short for common. This connection on this meter is common for every type of variable that the meter can measure. This is called a digital multimeter. Multi meaning it measures multiple variables. However, the black lead is common to all of them, whether it be voltage, resistance, frequency, actually the temperature, so on and so forth. So we stick the black lead in the black hole, make sure it's plugged in all the way. Now the red lead, you actually have three red holes. You have a 10A hole and a micro and milli A hole. So the 10 amp hole is a separate circuit for measuring larger values of current. The micro milliamp is where we'll probably be using it. And then over here on this one, we have the ability to measure voltage, resistance, frequency. There's a diode check, what they call a continuity check. We can check capacitors or temperature. So since we're going to be connecting or measuring resistance today, we're going to take a red lead and connect it to the red hole marked with ohms. So the deal is, folks, these meter leads are no good without the meter, and the meter is no good without the meter leads. So usually when technicians connect their meter leads to the meter for the first time, that's where they stay connected. They'll wrap the leads around the meter and throw it in their tool bag, but typically they won't disconnect their meter leads at all. So these little keepers that you have here, you can probably throw away. Now on the other end of the meter lead is the probe itself. The probe also has little keepers on the end of it that need to be removed in order to expose the conductive probe itself. So now what we're doing is got it ready. The next thing it says to do is select the resistance setting on the meter dial. So if we look around the meter dial, we see the ohm value. We also see this symbol here, which is a diode, and this symbol here, which is for continuity. Continuity is just an audible indication that 2 points are connected together. So we're going to be measuring resistance. So we're going to bring this over and set it on the ohm point. Notice it automatically comes up with mega ohms, OL. That's for over limit. Right now I'm trying to measure more resistance than the meter can actually indicate, which is the resistance of the air between the two probes. However, I have these other settings here. If I want to get to these, I have this select button. Notice in the display when I hit the select button, the little diode symbol comes in. The little V comes up. This is for checking diodes. We have a whole course on semiconductors. You'll learn that when you get there. The next thing we get to is a little speaker looking thing. That's the continuity check, and it's just an audible indication that two things are connected together. That's it. There'll be uses for it later, and we'll talk about it. But right now, we're going to get on with the lab itself. So, y'all got your lab sheet. I went and got some resistors, brown, black, green, gold, orange, black, brown, gold, yellow, violet, red, gold, so on and so forth. As we go through these, I'll announce them. However, I've already gone through and done the calculations. I got 2 5-band resistors, the rest of them are 4-band. All the 4-band are 5%. And then the 2 5-bands are 1%. I've done the calculations that the brown, black, green, gold is a 1 mega ohm resistor. It's 5%, and its tolerance is 950 ohms or 950 kilo ohms to 1.05 mega ohms. So we got the brown, green, gold resistor here. We're going to take it, make sure our meter's set up properly. It's in the resistance range. We're going to measure it and indicate whether it's good or bad. So we come in and measure it. Now notice it says de-energize the circuit or component, and it says isolate or disconnect at least one side of the circuit or component. I want to show you something. If I take and measure this resistor like this, by holding my fingers on the resistor, am I measuring the resistance? Am I measuring my body from fingertip to fingertip, or am I measuring both? Well, I'm measuring both, and I don't want to. Notice the value says 70, and it's moving around about 0.76 mega ohms. That's about, and we move the decimal point over, that 770 kilo ohms, all right, which isn't anywhere near that. But watch when I release my finger and measure just the resistor itself. Now it measures 1.008 mega ohms. That's why we have to isolate the component that we measure to make sure that we're not measuring anything besides that component. So 1.008 mega ohms is what we measured. And that does fall in between the two values, so we would indicate that that one is good. Okay, so the next one, orange, black, brown, gold. Orange, black, brown, gold. Orange is a 3, black is a 0 with 1 0 behind it. That's 300 ohms. Again, 5% to give us 285 to 315 ohms. So we measure and we get 297.3 ohms. 297.3 ohms. $297 is in between 315 and 285, so it too is good. The next resistor, yellow, violet, red, gold. Yellow is a 4, violet is a 7, red is 2 zeros to give us 4.7 kilo ohms. Our range is 4.465 kilo ohms to 4.935 kilo ohms. Take and measure it. 4.65 kiloohms. $4.65 is in between the 4.46 and the 4.935 kiloohms. Therefore, it too is good. Okay, so the next one is the brown, black, orange, gold. Brown, black, orange, gold. No, I'm sorry. Orange, black, orange, gold. Orange, black, orange, gold. That's a 0 with 3 zeros behind it. That gives you 30K to give you a range of 28.5 kiloohms to 31.5 kiloohms. So we measure it. We measured 29.48 kiloohms. 29.48 kiloohms. Okay, so the 29.48 kiloohms falls between the 28.5 and the 31.5 to give us another good resistor. All right, now the next one is the first 5 band. It's blue, red, black, black, brown. And I want to point this out to you because on the 5 band, it's digit, 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 then the number of zeros, then the percent tolerance. So blue is a 6, red is a 2, and black is 0. So I have a 6, a 2, a 0, and then the black multiplier tells me to put 0 zeros behind it to give us a total of 620 ohms. See, when black is a digit, you put it, the 0 down, but when it's a multiplier, you put 0 zeros, therefore you put nothing, okay? So that 620 ohms, we calculated to 613.8 to 626.2. Take and measure this one. 0.618 kilo. We move the decimal place over 3 places to the right and turn it into ohms at 618 ohms. So 613 to 626, 618 is right there. So it too is good. So the next one is gray, red, red, gold. Gray being an 8, red being a 2 with 2 zeros behind it to give you 8.2 kiloohms, 5%. So I'm going to take it, measure it. .07 kiloohms. That's not right. Okay. 8.2 EE3 plus 5% equals, that's 8.61 kiloohms. And 8.07 is what was measured. That 2 falls in between the range values to make that resistor good as well. All right. Okay, so the next one is a 56K brown or green, blue, orange, gold. 53.2K to 58.8K. $55.7K. That 2 is good. Okay, so white, brown, brown, gold. White is a 9, brown's a 1 with 1 0. That's 910 ohms, 5%. Gives us 864.5 ohms to 955.5 ohms. Take and measure it. Again, 0.893 kiloohms, move it over 3 places to make it ohms, 893 ohms. 893 ohms is definitely, again, in between. So it too is good. Okay, and then another 5 band, that's red, violet, black, red. That's a 2. That's a 7 with a 0, and then 2 zeros behind it to give you 27 kiloohms. 1% tolerance with the brown. That's 26.73 kiloohms to 27.27 kiloohms. So on this one, I want you to see, if you can, notice how that tolerance band is separated a little bit from the other ones, like we talked about. So we got 27K, we're going to measure it. .01 kiloohm. Pert near right on the money. Okay, now the last one, orange, white, orange, gold. That would be a 3, a 9 with 3 zeros to give you 39K, 5%. Is 37.05 kiloohms to 40.95 kiloohms. So we take and measure it. And we get 38.8 kiloohms. It does fall within the range itself, so that one too is good. Okay, so that concludes the lab, folks. Get this turned in to me, and we'll call it a day. All right.